This is Excel exercise number 02 for Finance 431, Fall 2013. Today we want to get some practice using some functions that are built into Excel related to bond pricing. Here's the basic bond pricing equation. It says the value or price of a bond is equal to the present value of its cash flows discounted back at the required rate of return. Typically, we know the cash flows on the bond, the coupon rate, and the face value of the bond. We either know the required rate of return and we can solve for the price, or we know the price and we can solve for the required rate of return. We'll be looking at how to do both of those things in Excel. The second equation we have here is our bond duration equation. We'll be looking at how to use that bond duration equation and applying it to some sample bonds. Down at the bottom here we have some sample bond quotes. We're going to focus on the one circled in red here. This is a Microsoft Corporation bond. The price is quoted as 100.69. Bond prices are quoted as a proportion of the face value, and for our purposes the face value will always be $1,000. So this bond is selling at 100.69% of $1,000. That relates to a dollar price of $1,006.90. We'll see that as we move through. The next column over is the coupon rate on the bond. This tells us this bond has a 2.125% annual coupon rate. It will pay 2.125% of $1,000 each year as interest. In other words, $21.25 per year in interest. The bond matures on the 15th of November, 2022. That's about 9 years from today. The yield to the maturity on the bond is 2.047%. It has a current yield of 2.11. The current yield, you may recall, is the annual coupon divided by the price of the bond. This is an investment grade bond rated AAA, the highest grade a bond can receive, and this bond is not callable. Microsoft cannot forcibly take it away from us before the maturity date. Let's have a look at task number 1 for this assignment. Task number 1 says if you know the maturity of the bond in years and its yield to maturity, you can calculate its price using the PV function. The PV function has a number of parameters that we need to supply to it. The first is the rate or yield to maturity on the bond. The second is the number of coupon payments on the bond. Next, the size of the annual or semi-annual coupon payment on the bond. And lastly, the face value of the bond. The last parameter out on the end here, the type parameter, is not needed. When we look at bond quotes, we don't necessarily see these values that we need directly for the parameters. Instead, we may have to calculate them. For example, if our bond pays interest more than once a year, which is the case in the United States, we'll have to take the annual yield to maturity and divide it by the number of coupons per year, typically 2 in the U.S. Likewise, to find the number of coupon payments, we'll have to take the life of the bond in years and multiply it by the number of coupons per year. Lastly, to find the size of the annual coupon payment, we'll take the coupon rate on the bond and multiply it by the face value. That gives us the annual coupon, and then we'll divide that by the number of coupons per year, typically 2, in order to get a semi-annual coupon. We have a sample bond quote down below, and our task is to build a spreadsheet template to estimate the value of the bond given its reported yield to maturity. When building spreadsheets, it's a good idea to separate the inputs or assumptions from the outputs or calculations. We'll use the bond quote circled in red down here for our example. The annual yield to maturity on the bond is 2.047%. The number of years to maturity is 9 years. That is from 2013, today, to 2022 is 9 years. The coupon rate on the bond, 2.125%. You see that number down here. The quote doesn't tell us that there are 2 coupons per year, but that's always the case for bonds in the United States. So 2 coupons per year. And finally, our face value, again, not indicated in the quote, but we'll always use a face value of $1,000. Let's calculate the value of this bond. First, we'll have to calculate the inputs as indicated up here. We'll start from scratch. We'll type equals PV, and we can see that Excel is prompting us for the inputs. A really handy feature is to come up here onto the formula bar and click the insert function after we typed equals PV in the left parenthesis. When we do that, a function argument box will pop up for us. The first argument here says rate. Rate is actually the yield to maturity, which is 2.047%, divided by the number of coupons per year in order to get a semi-annual rate. We see the numerical value here. It's a little less than 1%. For the number of periods, our equation says take the bond's life in years and multiply by the number of coupons per year. So it's a 9-year bond, and we'll multiply that by 2 coupons per year. We'll get a total of 18 coupon payments while we're holding this bond. For the payment, we'll use the payment equation up here. It says to take the coupon rate, 2.125%, multiply that by the face value of the bond, which is $1,000, and then divide that result by the number of coupons per year. So every 6 months, this bond will pay $10.625 in interest. Finally, the last parameter is the face value. We'll click on the face value field over here, and we've got a price for our bond now. Notice that Excel puts a minus sign in front of the price. That indicates we'd have to pay money to buy the bond. What I like to do is just put a minus sign in front of the PV equation to get rid of that negative. So the price of the bond is $1,006.38. To get the quoted price of the bond, we'll have to take the dollar price of the bond, divide it by the face value, and then multiply that result by 100. In other words, the bond is going to sell at 100.64% of its face value, according to our calculations. You may note that this number is slightly different from the price quote we saw on the previous tab. And that's because the bond doesn't actually have exactly 9 years to maturity. We're rounding the maturity to the nearest year. That's task number 1. Let's have a look at task number 2. Here's task number 2. Task number 2 says if you know the maturity of the bond in years and its price, then we can calculate its yield to maturity. We'll use the rate function to calculate yield to maturity, and it has a number of parameters. Number of periods, in other words, the number of coupon payments we'll receive, the size of the coupon payment, the present value or price of the bond, and its face value or future value. We'll have to calculate some of those parameters as indicated down here. Task number 2 is the inverse of task number 1. In task number 1, we knew the required rate of return, and we solved for the price of the bond. Now we're doing the opposite. We know the price of the bond, and we're going to solve for the required rate of return, or yield to maturity. Let's start from scratch here. We'll type equals rate and the left parentheses, and Excel will prompt us for the input parameters. As we did before, we'll come up to the formula bar and click the Insert Function button, and Excel will prompt us for the inputs. The first parameter is NPER, the number of payments we're going to receive from the bond. The bond has a maturity of 9 years. It's going to make 2 payments a year, and so we will get exactly 18 payments during the bond's life. How big is each payment? The bond has a coupon rate of 2.125%. We'll multiply that by the face value, and we'll divide by the number of coupons a year. The bond pays 10.625% every 6 months. Present value of the bond we'll have to enter as a negative number. So we'll put minus and the price of the bond in dollars. The negative number indicates a cash outflow. Lastly, we need the face value of the bond, which is $1,000. We can leave the type parameter blank and get our result. Because we entered semi-annual cash flows and time periods into the equation, we're going to get a semi-annual yield as a result. In order to find the annual yield on the bond, we'll simply take the yield to maturity and multiply it by 2. That finishes task number 2. We know the price of the bond. We're trying to solve for the yield. Next, let's have a look at task number 3. This is task number 3. It's very similar to task number 1, where we solved for the price, given that we knew the yield to maturity. The difference here is that we have, instead of a number of years to maturity, we have something known as the settlement date and the maturity date. We can think of the settlement date as the day we're going to buy the bond, and the maturity date, of course, is when that bond matures. You'll note these two dates are about 9 years apart. That's why we use the number 9 in task number 1. So in this example, instead of knowing the number of years to maturity, we know the calendar date of the maturity of the bond and its yield to maturity. We'll use the price function in order to calculate the price of the bond, rather than the PV function as we used in task number 1. The price quotes we see down here were taken from the internet on September 16, 2013. So that's our settlement date in the input section. You can see that the bond matures on November 15th, so we enter November 15th, 2022 in the input section. Coupon rate on the bond, 2.125%. And now we see the yield to maturity on the bond, which is 2.047%. Here's our yield down here. Finally, we'll use a $1,000 face value and 2 coupons per year, as we did before. We're going to use the price function in Excel to calculate this bond. Let's go ahead and do that. We'll type equals price and the left parentheses, and Excel will prompt us again for the inputs that we need. As we did before, we'll use the insert function button, and it'll give us a box asking for the parameters. One thing that I like to do is list my inputs as close as I can to the same order as the parameter list over here in Excel. So first it wants the settlement date and then the maturity date. Here the word rate has a different meaning. Rate in this case is the coupon rate onto the bond. Coupon rate is 2.125%. And lastly, it wants the yield to maturity, 2.047%. You have to put in a few more parameters. The redemption is a tricky one. It says the redemption is the security's redemption value per $100 of face value. In other words, at maturity, how much do we get back per 100 of face value? We always enter 100 for the redemption value. We're going to get back 100% of the face value at maturity. There's one more parameter we need, and that's the frequency, or number of coupon payments per year. If we look here, we can see Excel has calculated our bond price for us. We'll go ahead and click OK. And Excel tells us that the bond is selling for 100.65% of its face value. To convert that to a dollar value, we'll simply multiply by 10. 100.65% of 1,000 is 1006.48. That's task number 3, finding the price of a bond given its yield and calendar dates rather than number of years to maturity. Let's have a look at task number 4. This is task number 4. It's a variation of an earlier task, number 2, where we were trying to solve for the yield given that we knew the price. The difference in this case is that we know the maturity date of the bond rather than as a calendar date rather than number of years, but we still know its price. In this case, we're going to use the yield function as highlighted here. The yield function has a number of parameters we'll look at in just a moment. Here are the input parameters for the bond. The prices were observed on September 16, 2013. Bond matures November 15th, 2022. The coupon rate on the bond, 2.125%. And the dollar price of the bond, I went ahead and entered it as a dollar price. We could have put in the quoted price. Quoted price was 100.69. That converts to a dollar price of 1006.90. Bond has a face value of 1,000, 2 payments a year. So let's calculate its yield to maturity. We'll start from scratch. We'll type equals yield and the left parentheses, and Excel prompts us for the input parameters. As we did before, let's go up to the top here, click on the function argument box, and enter our parameters. The first parameter we need is the settlement date, then the maturity date. Here rate refers to the coupon rate on the bond, and PR is the price per 100 of face value. Now I entered this price as a dollar price, so we'll have to divide by 10 to get back to our quoted price. If I had simply entered the quoted price, we would not have to make the adjustment here. We need the redemption per 100 of face value. We're always going to set that parameter to 100. And finally we need the frequency, the number of coupon payments in a year. Excel has calculated our yield to maturity as about 2%. There it is, 2.042%. So this is task 4, calculating a bond's yield given that we know its price. And we have calendar dates rather than a number of years to maturity. Next we'll have a look at task number 5. This is task number 5. In task number 5, we want to calculate the duration of a bond. We're going to assume here we know the calendar date of the maturity of the bond and its price. Here's the function we use to calculate duration. You'll notice the duration function needs the yield, but we have the price. So we'll take the price first, calculate the yield, then once we have the yield, we'll calculate the duration. We're using the same bond as in the prior example. We have all the same input parameters here. First thing we need to do is calculate the yield. You can refer back to the earlier task when calculating the yield on the bond. And then we'll calculate the duration. Let's start from scratch here. The modified duration is calculated in an identical manner. We simply have an m in front of the duration part of the function. The rest of the parameters are identical for the duration function. This is task number 5, where we calculate the duration of a bond and the modified duration. Next, we'll have a look at task number 6. This is task number 6. It's identical to task number 5, except now we already have the yield on the bond instead of its price. We're going to use the duration and mDuration functions to calculate the durations of the bond. We have the same set of input parameters. As in the prior examples. Because we already have the yield on the bond, here in cell B27, we can proceed directly to the duration and modify duration equations. We do not have to calculate the yield first. We're already given the yield. So the process here is identical to task 5 once we had that yield calculated in task 5. Next, we'll have a look at task number 7. This is task number 7. It's a variation of task number 5. We know the price of the bond, and we want to find its duration. The difference here is that we have the maturity in years. We do not have a settlement date and a maturity date. The problem for us is that the duration equation insists that we know the settlement and maturity dates. So, we're going to create our own settlement and maturity dates, as shown here. We have a number of years to maturity, 9 years, and somehow need to turn that into a calendar date. The rest of the parameters are listed here. The first thing we have to do is calculate the yield on the bond. But even the yield function requires a settlement date and a maturity date. So we're going to come down here in these two cells and generate our own settlement dates and maturity dates. I'll show you a little trick. For the settlement date, we're going to use the today function in Excel. We're going to assume that the bond is being purchased today. The trick is in generating the maturity date. The function is rather complex, but what it does is it takes the current year and adds to it the 9 years to maturity. And then it uses the current month and the current day. So basically all we're doing in cell 35 is adding 9 years, because the bond has a 9-year maturity, to the settlement date we generated. Once we have the settlement date and the maturity date, we can calculate our yield, and once we have our yield, we can calculate our two durations. So for this example, I should probably have moved the yield down below the settlement and maturity because we can't calculate the yield without those two numbers. But in any event, once we generate those two numbers, the yield will calculate as it should. Then we use our standard duration and mDuration functions to calculate those. That's task number 7. Let's have a look at task number 8. This is task number 8. Task number 8 is identical to task number 7, except now we have the yield on the bond and not its price. Because we have the yield, we can proceed directly. We don't have to calculate a price first. However, we still don't have a calendar settlement date and a calendar maturity date. So we'll generate those down here just as we did before. We'll take today's date and assume that's the settlement date, and because the bond has a 9-year maturity, we'll add 9 years to the current date. Then we can proceed to calculate our duration exactly as we did in the prior task. That's task number 8. I hope this tutorial has helped.